Hi. Good evening, everyone. Am I audible? Okay. I am Sriram Adhitya. Today, I'm going to be presenting about the impact of 3D printing in architectural design. Before we start, a little bit about our practice. I'll start by saying a few words. Uh, m- Myself, Vamsi, and Balashamukam, we graduated from School of Architecture and Planning in 2012. Post that, we started our practice in Coimbatore around 2016 and eventually moved to Chennai. We work on like diverse architectural projects. In 2022, we collaborated with Vasta, uh, an Indian startup, a deep tech focusing on 3D printing, founded by three alumni from IIT Madras. So we were asked to design a pioneering project that should potentially highlight the benefits of 3D printing or also to push its limits. So the project is a guest house within IIT campus. It's for the delegates, and the design is this. Yeah, we have been working on this design for 2 years now. So whenever we work on a design, we usually don't usually start off with one single idea. We wait for a confluence of ideas to occur. Here again, we had multiple thought processes. One, as I said, it has to push the boundaries of 3D printing. Whatever is currently happening right now in the world, it should push the boundaries. It should be better than what others are doing. It will be more complex and things like that. And other, concrete is often perceived as a rigid material. We want to break this notion, challenge it, make it look more like a fabric. And again, I think most of us would have been to IIT campus. It's full of trees. It's within a very natural context, and our design has to look very harmonious. That was again one of the main intent. And one other intent was, so this design has a very futuristic feel to it. As an interesting contrast, we wanted to add some traditional elements to it so that the building doesn't look very alienistic. Even though it's futuristic, it should feel like it's an extension of your own future, not someone else. So that was again one of the ideas, and the construction is currently ongoing within IIT. As I said, we have been working on this design for 2 years now, and it has been a wonderful experience and a lot of learning. I would like to share here very briefly within the short amount of time what additive manufacturing is and how it can affect our design process. And yeah, so what is concrete 3D printing? Concrete 3D printing or additive manufacturing is an automated process where a system extrudes or deposits concrete layer by layer based on a precise specification fed by the software. Basically, you feed your model into the software, it slices it, and then feeds it to the printer. I mean, very simply said. And yeah, and then when it comes to 3D printing, there are two major components. The one is the material, and other part is engineering. So when it comes to material, we have three different materials now. So all these are like proprietary permutations developed by Vasta itself. So one, we have a sustainable mix, which uses certain construction debris. And other, we have a structural mix that offers better strength. And third, we have an aesthetical mix that gives you a better finish. And again, when it comes to engineering, again, there is a software part and the machinery part. Software part, you have, again, this is a proprietary software developed by Vasta. They have their own slicing software where you input your model, and then it analyzes it, makes sure it's printable, slices it, and feeds it to the printer. And when it comes to machinery, you have your on-site printers and off-site printers. On-site printers are like huge gantry printers. It can build the whole structure automatically. And again, you have like pole printers, and there are robotic arm printers. And off-site printers are, again, you have smaller gantry printers or production printers, and even robotic arm printers. Yeah. So now we have seen what concrete 3D printing is, and we have a working model. But a point to note here is that the printed model, it's not homogeneous. It's printed layer by layer. That being said, it has different physical properties, just like a brick has and a concrete has. So we had to test for all of these parameters before taking it to construction. So yeah, we kind of did all of this testing in IIT and SCRC. It took us like a whole year to do all of these, and now we have a workable model that we can take it to construction. Yeah, this is one of the tests that we did in IIT. Okay, now I want to discuss with you about the workflow. A typical architecture project has a workflow. Uh, there are certain parameters we follow. There are certain standards that we follow that are in agreement with our consultants and contractors. It's the same here. However, uh, the concrete 3D printing technology offers a slightly different workflow. And again, there are a lot of parameters that will influence your design. For example, let's say you have your architectural model here, and it goes next to the DFAM team, where the DFAM team, again, they are a group of architects. They will use certain parameters of what is the maximum inclination it can print, what is the printable width, what is the wall size, and you'll have to take all of these parameters into your design. And again, when it goes to structural part, structure, as of now, we haven't gotten the IS codes formulated for 3D printed material as it is. So we have to treat it like a frame structure. That means you will have to integrate your columns, beams, and slabs within the 3D printed structure. Let's say you have a 230 column inside. Adding your printing thickness, your wall thickness might go up to 300 or 350. Something. And when it comes to structure, one of the major things to consider is that the sequence of work itself will vary. How you will integrate the structure within your design, that will be a major variable. And again, when it goes to MEP, how would you integrate your electrical conduits? How would you integrate your HVAC systems? All of these works has to be premeditated. And each one of these parameters will eventually influence your design and the DFAM design. Even the material, each kind of material will give you different options for structural and also DFAM design. Again, when it goes to printing, let's say you have an on-site printing and an off-site printing. On-site printing will offer you different structural techniques, and on-site printing will dictate different structural methodologies. Again, when it goes to construction also, there are a lot of parameters that will go back and influence your design. What I'm trying to say is that we will have to be aware of the entire system so that you can come up with a design that's printable. So this is like a sample wall. Let's say I have my architectural wall here. So when it goes to DFAM design, what the architects from DFAM team will do is that they will create something called an infill pattern. So this is an infill pattern from IIT project. So what this infill pattern is created for workability and printability. So this particular infill pattern is designed in such a way, the start and, okay, the laser doesn't work. The start and end points of the infill pattern are in the same location so that the printer nozzle doesn't have to go all the way to the other end of the model when it's jumping layers. Again, that's one example of how we could integrate structural column inside. And these panels are quite heavy, so maybe mostly a ton or 2 ton each, depending upon the size. And they have to be lifted if they have to be assembled. So we provide something called lifting pockets, where we introduce like a U-shaped rod and grout it inside. And again, when it goes to assembly, there are certain things that has to be taken care of. Like here, we have designed like a tongue and groove joint so that the panels can lock in position. And again, even the panel sizes has to be designed based on the workability and even the printability. Okay. So this is like a typical floor plan of IIT project. You have the columns, you have the lifting grout, single rod grouts, and everything. These are the printed panels. Yeah, this is us doing a dry assembly at the factory. Yeah, so all the panels are printed now. We have started the construction. I don't have the latest pictures. So that you can see the foundation there, and these are the printed panels. So this is one other project that we are working in Goa. We recently got approval for it, and hopefully we'll start the construction in the next 2-3 months. Yeah, that's it. So concluding the topic, I would say personally as an architect, this technology opened up. It has changed the way that I perceived architecture. It had opened up for new ideas. It has given me new opportunities. That's what I would say. I mean, it's a very subjective opinion. I feel it has a lot more potential. Yeah, that's it. Thank you. Thank you, everyone. Thank you for the opportunity. Thank you.
Thank you so much, Sriram, for that wonderful presentation. Can we please have a round of applause for him, ladies and gentlemen? Without any further ado, may I please invite on stage Nitin Sri Kumaran and Benny Kuriakose from Benny Kuriakose and Associates to kindly join us on stage, please, and to felicitate Sriram. We have Mr. Nitin from Fluidra. Just 1 second. Can we have that together, please? Like just 1 second. Congratulations. A group photo op, that would be nice. Thank you. Thank you so much, gentlemen.